Hi there. So I'm going to show you our picture frame demo for the laser cutter. And I'm going to do this here in the Digilab with my mask off so you can read my lips if you need to. But this is obviously a very confined space. So if you're ever in the Digilab, please remember to follow all the COVID precautions carefully. Right now the door is locked. I'm the only one in here. No one else is coming in here today. So I think it's okay. But here we go. For the picture frame demo, what I have here is the Rhino file with various two-dimensional lines. So you can see that these are just lines. These are not three-dimensional objects. These are just curves. And so I drew them using the top viewport. And we've got this outer curve, we've got the inner curve, we've got this blue rectangle here, which represents the size of the glass pane that you'll all be using. So this is my demo with just a vinyl cut of my logo on there. But this is the same size of glass. So you can see that on edge, it's very thin. And we can etch into the surface with the laser. Can't cut glass with the laser, but you can etch it. Or you could attach a vinyl cut to it like this. And then, of course, but this is just a frame of glass, right? It's sharp edges. You can't hang it on the wall. So we're going to make a picture frame using thin wood called Luan or veneer board, which looks something like this. So it's basically a plywood product, but it's very thin. It's like 3 layers. This stuff is actual veneer, meaning it looks like wood grain on both surfaces, which is nice. That's a little bit higher quality. And the Luan is this stuff that has kind of a pink color to it. And it has these stripes because it's made up of little strips of scrap wood glued together like plywood. So basically the same thing, but the Luan has a little more glue, and the veneer board is a little bit nicer. So you can buy either one depending on your preferences. Okay, but so to explain this file, and then I'm going to jump over to the Digilab PC where I can show you the Boss Laser software. So right now we've got the Rhino file, and so I've separated this out into layers. So you can see in the glass logo, I have, if I turn all my other layers off, you'll see the glass is 7 inches by 9 inches, and that's that blue, darker blue rectangle. And then my logo here is that same logo, but now it's designed to be etched with the laser. So I have the boundary curves drawn out using polyline or polycurve. And then to fill in these areas, remember the laser could etch these lines, the boundary lines. That's great. But to fill in the area, if we did a raster of a solid, this is going to take a very long time because it's going to step over just the width of half the width of the laser, or the width of the laser line. So it's going to be a long cut. So instead, I'm using hatch marks. And so you can do that, remember, by just typing in hatch in the command bar. And that allows you to select the boundary curves. In this case, I had this lower triangle selected. And then you can select one of these preset patterns, and you can change the scale or the rotation. So you could do like 10 degrees, and then click in the other box, and you see that the pattern will rotate 10 degrees. You can even choose solid in here. So if you really wanted to etch a solid pattern, then that could work. You could do that maybe between 2 lines that are close together, or something where it's not a ton of area. But we just don't want to max out. We don't want to take days and days to etch these on the laser if possible. So try to use your design skills to fill in an area without necessarily making it solid. So I've done that I'm going to cancel that because I want this to be open, but I've done that in the background here where I've just used this plus pattern, and I've scaled it down so that it should look like a fill of this background circle. And I had to do some creative kind of trimming here. You can see that it's not one circle that's being overlaid by the other, because the laser cutter is a 2-dimensional tool. So it's not understanding things on top of other things. It's just seeing it all as a flat image or a set of lines. So anyways, these are separate hatch areas from each other. And of course, this is a separate one as well. So what I want ultimately to end up with is that the laser is going to etch the white lines just as a continuous line, and then it's also going to etch the hatch lines as well. And so that's what I'm going for. And so we can't cut the glass on this, but if we go to the wood layer, we can turn off the glass layer and forget about that. And so this is going to be, I have 3 wood layers, and this is important for the structure of your frame, and you'll see the example. So hopefully this will make sense by the end. Layer 1 is the top layer, so this is the surface that you're going to see as the picture frame. Layer 2 is an intermediate layer, because we've got this pane of glass, and so how are we going to hang it on the wall? How are we going to capture it? We need to sandwich it between wood. So we could, this is thinner than the Luan, right? So if we hold up the Luan next to it, or the veneer board, they're both thicker than the glass. So what we could do is we could put a front face of wood, and then a middle layer of glass, and then a backing of wood. So we sandwich it between. But the glass has a thickness still, so you know, we could etch into the wood here with the laser, but that's going to take a lot of power and a lot of time, so it's not going to be very efficient. So I'm going to make a stack of 3 pieces of wood. We're going to have the front face of the frame, then we'll have the second layer be just the part of the wood that goes around the border of the glass frame, just to act as a spacer. And then the third layer of wood is going to be the back of the frame. Okay, so hopefully that'll make sense. But that's why I've separated these out, because each of those layers is going to be a different cut job. It's going to be a different cut pattern on the laser. So you can see here, this is the middle of the sandwich. We talked about the front of the sandwich here. It has a hatch pattern, the pink. And make sure I turn off the purple layer. So the first wood layer, again, has red cut lines. We're going to cut all the way through the wood to make this shape. And this interior rectangle is slightly smaller than the glass, so it's going to trap it inside. So that's good. We want it to be smaller than the glass. Then I've given it a hatch pattern just for some interest. The second wood layer is the middle of the sandwich. So this is just a spacer. You won't see this. You'll only see this on the outer edge of the frame. You're not going to see it on the front or the back. I'll talk about the circle next. So the second layer is just a spacer. Then the third layer is also a bit smaller than the glass. So it's actually going to trap the glass between the first and the third layer. And turn that back off. And this third layer has a little keyhole. And this keyhole is where you're going to hang it on a nail. So you could put the head of the nail will fit through that hole and then slide up into the thinner slot, which should trap the nail head back behind the frame and hold it in place. And that's why we have this circle in the second layer. This is a spacer. That's just to give it a little bit of room for the nail head to slide in there. So, so here we are. Once we cut these 3 separate things, then we'll line them all up, glue them together with the glass inside. Okay, so now how do we go to actually, we got lines in Rhino, but how do we move them to the laser cutter? So we need to export these, and that's why they're on different layers, because we want to export each of these layers separately, because they're going to be a separate cut job. So making sure that you only have wood layer 1 active and visible, you can go up here and go File. First, I guess we should select it. And then we're going to go to File, and we're going to go to Export Selected. Export Selected. Okay? And you should have already made sure that your units are proper. Everything is lined up in Rhino at the right unit. So mine was modeled in inches because the glass was cut to 7 by 9 inches exactly. The laser cutter works in millimeters, so we'll have to double check that unit is held steady. So I'm going to find my USB drive, and I'm going to export wood layer 1 as an Adobe Illustrator file. This is the type of file that the laser software uses, and so it's the best way to go from Rhino to the laser cutter, Adobe Illustrator. Even though we don't even open Illustrator, you don't have to know anything about Illustrator, you just need to export it as an Illustrator file. Okay, and I'm going to title this is important, so please title this with layer 1 somewhere in the title. So frame, I'll do my name first, so Bailey, frame, layer 1 as an Illustrator file. Okay, export that, and we're going to preserve the model scale when we make an Illustrator file out of it. So 1 inches should not equal 1 millimeter. 1 inch should equal 25.4 millimeters. Okay, and you can double check that if you forget. Just Google it. Hatches should not be exported as solid fills. They should be exported as lines because the laser cuts with lines. So I'm going to uncheck that. Okay, so both of those are important. We got to double check those units and the hatches if you're going to use hatches as a pattern. Okay, so let's export that. Okay, and then I'm going to also do the same thing for layer 2 and layer 3. So you're going to turn off layer 1, just select everything, go to File, Export Selected, as an Illustrator file, you go Bailey, frame, layer 2, on the USB, as an Illustrator. Again, you want to double check that all of these are as you left them. Okay, and again with layer 3. I'll skip that because you know what to do, but highlight everything, export it as Illustrator, and then we'll jump over to the PC and the Boss Laser software. Thanks.
Okay, so the program that runs the laser cutter is called RDWorks. You can see that there's a normal work area. Up in the upper right is where you have your layers window. Below that, you'll have the layer settings. You have the start and download buttons in the lower right. We've got these colored squares at the lower left, and we've got the normal file menus up at the top. So to get started, just go to Import and find your file that you exported from Rhino. It should be an Adobe Illustrator file. So you can find that on your USB drive and just open that up. You should see a little preview that shows you the line work inside the file, but sometimes it looks different in the preview than in the image or in the actual program. So bring it in and you'll see that you can resize it. We don't want to resize it because we've already set the scale in Rhino. But you can see that it's all imported on one layer, the black layer at the top. You can see that each layer has its own power and speed setting. So to change that, you can click on one of the colored squares in the lower left. By clicking on the red square, we've now changed everything that's selected to be on the red layer. So when you've selected a layer, you can come down below and alter the minimum and maximum power settings as well as the speed settings for the laser. There's a cheat sheet in the DigiLab that has power and speed settings for many different materials. To cut through Luan, we're going to use 80% power and a speed of 10 millimeters per second. The layer should be set to cut mode, so the laser will trace the lines as a vector rather than scanning across like a raster. In cut mode, the laser will follow the line and etch at the power and speed settings that we've adjusted on the layer. Changing it to scan mode will cause it to act like a raster where it goes back and forth across the whole area, firing the laser intermittently to create an image. We'll use the scan mode when we go to etch our glass image, but to cut through the wood, we're going to use cut mode. Notice that cut mode doesn't necessarily adjust your power settings to cut through your material. You still have to manually enter the proper power and speed settings to cut through your material. So you could use cut mode and set the power settings lower just to etch lines into the surface. So it's a little bit confusing, but cut mode doesn't necessarily mean it will cut all the way through your material. So whenever you're satisfied with the settings, you're going to hit download and then type in a name, just a short name to recognize your file on the laser interface. So go ahead and hit OK. And this will download your file to the laser itself. So you can hit OK and then go over to the laser to start the cut. Oh, one last thing I forgot. You want to look at the rulers on the edge of the workspace to double check that your cut file is the proper size. There's a chance that things can get resized accidentally as you export them from Rhino. So you want to just double check that the scale of your object is what you expect. RDWorks should be installed in inches, but some versions of the program run in millimeters, so just pay attention to what units are being used. Okay, so now I'm going to do the same thing. I'm going to import the top layer of the picture frame, which has these hatch marks to give it a pattern. And I'm going to do this to hopefully explain a little bit better how the layers and power settings work. So you can see when you import your design with the hatch marks, it's all imported onto the same layer. So the hatch lines and the cut lines are both set to run at the same power. But this is not what we want. You can see on the layer, we're set to cut mode, but our power is only 35 and the speed is pretty high. So we're just going to be etching the surface of the Luan. Those settings aren't high enough to actually pierce through the wood. So that's great for the hatch pattern, but we're going to need to change the power settings and the speed setting to actually cut out the object and pierce through the wood around the border. You can see that the hatch imported in a way that you can select each individual hatch line separately. So we want to be sure that we're selecting the whole set of hatch marks so that they all end up on the same layer. We don't end up losing a few of our pattern along the way. So you can do that just by dragging a selection box. But if you zoom in, we can select the border lines. So if you hold Shift, you can collect both at the same time. And then we're going to go down to the boxes in the lower left and click on a new colored box to move those selected lines to a new layer. But in this layer, we are going to change the power settings to be 80% and the speed to be only 10 millimeters. On the black layer, remember, we're etching at 35 and 350 millimeters per second. So the black lines now are going to just etch in the surface and not pierce the wood, and the red lines are going to cut all the way through the wood, so we have a separate object. So this is looking a lot better. That's what we want. Remember, both layers should be in cut mode, but the power settings are going to determine how deep that cut will actually pierce into the material. The cut mode is going to cause the laser to trace each of those lines, the hatch lines and the border lines. And that's going to be more efficient than if we change it to a scan. Now the scan could also create the same pattern, but it's going to take a lot longer because the laser is going to move back and forth across the entire work area to create a raster. And it's going to intermittently fire the laser anytime it crosses one of the lines. So the laser is amazing. It can do all of that effectively, but it's going to be a lot slower than if we have it only trace the line. So it's only moving across the surface where it's actually needed. So make sure both layers are on cut, but that the power settings are appropriate for each layer. And now we should see the laser actually travel along each of those lines and fire at the appropriate power setting. So when you watch the laser actually move, this will be a much more efficient pattern. Okay, so let's go through again, double check, make sure everything's ready to send to the cutter. Both layers are in cut mode. Both are outputting yes, meaning they're going to be sent. The power settings are appropriate, and then we'll hit download and give it a new name. We could say layer 1, top layer, whatever you want. Okay, then I'll give this another name and send it to the cutter. Then I will repeat the same process for the third layer of wood. And then in the next section, we'll move on to talk about etching the glass. Okay, so I've cut all 3 layers of wood, and now I'm going to talk about importing an image into RDWorks so that you can actually etch an image onto glass or any other material you want. So it's the same import process. Go to File, Import, find your image file. In this case, the image file should be either a JPEG or a .bmp or bitmap. You see a bitmap is already black and white, and you can create a bitmap using Photoshop or another program. But you can also just start with a JPEG. So I'll open that up, and it imports as a black and white image. And that's okay because the laser is only going to be concerned with the power settings. It's not able to do anything with color. So you can resize your image. The placement of the image is not super important, but you can resize it if it's not the size you want. Just pay attention to those rulers on the sides. Dragging the box from the corner should preserve the scale, the aspect ratio, so you're not distorting the image. And you want your image to be about 4 by 4 inches. We want all of our images to be about 4 by 4 to fit nicely on the glass and give us a lot of room as a border. So anywhere around 4 by 4 inches, and it should be on a layer that is a scan mode layer. And you can see that it's already reading it as a bitmap. So it knows it's an image. And we're going to change the power and speed settings and make sure that it's in scan mode so that the laser is actually going to etch the entire image. Now you can go up to the BMP button in the top, and that'll open this dialog window where you have Bitmap Settings. So you can actually adjust the image right in RDWorks. This is really helpful because what makes a good photography image doesn't necessarily translate to a good laser cutter image. So you can change the brightness and contrast and change the dithering and stuff. After you make a change, be sure you hit Apply to View so that the window updates. So you can hit Invert Image so that your darks become lights and vice versa. And that can be nice because wherever you have darks, the laser is going to fire. And wherever you have full white, the laser is not firing. So the darker the image, the higher the power setting the laser will fire at. So that's why you're adjusting the brightness and contrast here, is to try to get a nice balance of darks and lights so that the laser actually etches, but still leaves a lot of detail of your image. So just play around with the sliders and hit Apply to View every time you make a change. Now you can also use the Dither option to change the way that the computer is dithering or creating the mid-tone fades. So if you go to black and white, you only have full black or full white. And that is sometimes closest to what the laser is actually going to give you because it's firing at a certain power where it's black and it's not firing where it's white. But this kind of grayscale dithering will hopefully allow the laser to etch at an intermediate power setting between the minimum and the maximum and give us a little more nuance. You can also hit the Get Outline button, and that will create a vector file where it traces each region of different value. And then that can be a vector file that you can use on a cut layer to create the image by tracing the outline. Okay, so this is obviously really complicated in these gray areas. You have so much information, too many vertices, so I'm going to cancel that. I just want to use the scan mode in this case to etch this image into the glass. Okay, so I'm adjusting my settings now. I want to invert my image. I want to give it enough contrast that we see the difference between the darks and the lights, and still retain some of the nuance. When you're satisfied, just hit OK, and that will have applied to the image. It doesn't look that different, but if you click on it, it should update to have your settings. And now we're going to double check again that the scale is correct. It should be about 4 by 4 inches. And now we're going to go over to our speed and power settings. We want to be in scan mode. Go ahead and double click the layer to open up the detailed layer parameters. Now you only have the option of scan here because it recognizes that you're working with an image. So you want to be in scan. You want your minimum power and maximum power to be the range of your grayscale in your image. And I'm looking on the cheat sheet in the DigiLab to tell me the power settings to etch glass. And it tells me that the min and the maximum power settings should both be 27. Now you could change this and you could have the min be lower than 27, but don't go above the maximum recommended for each material. The speed should be set to 325 millimeters per second. By setting both the min and the max to 27% power, I'm only going to have one depth of etch. So it's only going to be on or off, but that's okay for my image. And then the final parameter that you need to pay attention to in the scan mode is the interval. Now this is not available if you're working in the cut mode, but in the scan mode, the interval is going to help determine how deep the cut is. It's basically asking how many times per distance should the laser fire, and this is in inches. So the cheat sheet is actually in millimeters, so you want to double check that your units are proper here, but you want to enter the interval that's appropriate for your material. For glass, that's 0.0026 inches. All right, then just the final check before we send it to the cutter. We've got a scan mode. Our image is properly sized. The power settings are set. We can go ahead and hit download, give it a new name, and start the cut. Okay, hopefully that gives you a sense of what to do in the DigiLab to run a cut on the laser cutter. Thanks for watching.